As we start Chapter 2, we're going to give you some basic material in regard to working with equations, going over some terms, and strategy. So we'll start by defining what is a term, then later like terms, and the word coefficient. And I put this as sort of an extra example so we can use this to define what is a term. Well, basically a term is something that is separated by either a plus or minus sign. And here we see then we have 1, 2, 3, 4 terms. Now notice there is no sign in front of this first term, and that is because it's positive. If it's positive, we don't have to put the sign there. Now notice that in this particular term, for x to the third, there is a variable, which is the x, that is raised to the third power. Now it would only be the x, not the 4. Now the 4 is the numerical part of the term and is what is called the coefficient. Sometimes you'll see something like this, x to the third all by itself, and it appears there is no numerical coefficient. Well, there is actually a 1. When there's a 1 there, we don't put it. So every term, in a sense, has a 1 in front of it if it's not there. So, with this in mind, let's take a look at identifying the numerical coefficient of each term. And we can just outline these. So for letter A, it would be a 9. For letter B, it would be a -3. Now for letter C, which is a -x, we would put the 1 in there. So the numerical coefficient would be a -1. Now here there are 2 variables. We are only interested in the numerical coefficient, which is 2.7. Now, another term that we want to look at is whether something's a like term or not. And by definition, something is a like term if in the variable part the exponent is the same. So here we have x to the third, x to the second, x to the first. Again, if there's no 1 by the exponent, or there's nothing by the exponent, there is a 1 there. So these would not be like terms. So if you had, for instance, a b to the second, and another one was a to the second b, they have the same variables, but since the exponents are different, these would not be like terms. Now if we had something like this, a, b, and another one was b, a, even though the order is different, these would be like terms. We could use the commutative principle to switch those around. So let's do this part. Are these like terms? And x to the first, yes. Now here we have what we actually mentioned up above, y to the second, y to the first. So these are no, not like terms. Now here we have an AB, here we have a BA. Again, they're not exactly the same, but they are like terms. Here we have x to the third, x to the third, y to the first, y to the first, z to the second, z to the third. So no, they almost were, but not. Okay. In example 2, we're asked to do something very common throughout the rest of our algebra, is to combine like terms. So a strategy, and some of you can do this horizontally, but I would suggest line them up like so. 7x minus 2x. This would be like a like term column, and then a plus 4. So this is going to be 5x plus 4. Now you might say, why am I lining them up? And the reason is it helps organize your like terms. Again, you could do it horizontally or mentally once you identify them. But another way is negative 9y, and then you have a positive 1y. Now there wasn't a 1 there. I put it there just to help with calculations. Then we have a plus 2, a minus 1, a plus 6, and a minus 7. So this would give you a negative 8y. And let's see, we have a negative 8 and a positive 8, so it's just going to be a negative 8y. This just ends up being a 0, and we don't write that. Now for something like this, you have a 1.6 x to the fifth and a negative 0.3 x to the fifth. And if you're noticing, when we combine like terms, we only deal with the numerical coefficients. The variables never change. So here, this is just going to be a 1.3 x to the fifth. And then we had a, right there, a plus 0.9 x to the second. All right, let's clear that up. Going on to number 3. Simplify each expression. Use the distributive principle to remove any parentheses. Well, we've done some like this before. This will be 3x plus 18. Now, an interesting observation here is when there's a negative sign in front of a parenthesis, basically the only thing you have to do to remove the parenthesis is just change all these signs. So once again, if there's a negative in front of a parenthesis, the only thing you need to do is to change each of these signs. So this would become a positive 5m, a negative 6n, and a positive 2p. By removing the parenthesis when there's a negative sign in front, just remove the parenthesis and change each of the signs. Now you could also stick a 1 right there and just multiply. Negative times a negative gives you a positive. Negative times a positive gives you a negative. Negative times a negative gives you a positive. The shortcut, negative sign in front of a parenthesis, just remove the parenthesis, change each sign. Now here, 1/3 of 6 is 2. 1/3 of a negative 9 is a negative 3. If you have any questions, be sure you're asking them. Here it gets just a tad more complicated, and be careful what you're doing. Here we are to remove the parentheses and then simplify if we have like terms. So 14 times 2, 28x. 14 times 6 is a positive 84 minus 4. So we see we have like terms here. So this becomes 28 plus, or 28x plus 80. Again, you would write the example down on your blue sheet, show this next step, and do the simplification. An error that sometimes occurs is a student would multiply this 14 by the negative 4. You're not authorized to do that. Only what's in the parenthesis. So here we have 10a minus 5. Now we do the multiplication. Negative 2a. Watching the signs, a positive 6. Now for something like this, you can do it mentally. Your like terms are the a's. So this gives you 8a. And then a negative 5 and a positive 6 gives you a positive 1. Now again, they're combining things as we prepare for working with equations in our next section. This is 6x minus 15. Now here's a case where there's a negative sign in front of the parentheses. You could put a 1 there if you like, and that would be then a negative x and a negative 7. Or just remove the parentheses and change both signs. Now we combine like terms. A 6x and a negative 1x, if you want to put it there. And then this, a negative 15, negative 7, negative 22. In example 4, we need to be very, very careful as we write each phrase as an algebraic expression and then simplify. So we're going to add this to this. So adding, we don't have to worry about any signs. Negative 4y plus 3. We just want to deal with strategy. And we're adding it to this, so we can just put it right here. Plus 6y minus 9. Now we've put them in like term columns. We just add them up. 2y minus 6. Now the key to all this is that you want to be sure you have the right answer. Now in this next one, this is where many students will make an error. So pay particular attention to this. Now this says subtract. So what I'm going to do, I'll do it up here. 2x minus 1. Now they want us to subtract that. So I'm going to put it in parentheses and put a negative sign in front. So I've converted subtract this from this. So I'm now going to write that 3x plus 7. Now when I subtract this, what happens here? Remember, this is in a sense in a parenthesis because that's what you want to do. Well, what we do when it says subtract is we change each of these signs. So this 2x now becomes a negative 2x, and this negative 1 becomes a positive 1. Now, you might skip this step if you want, but when you see the word subtract, just change both signs. This will become a negative. This will become a positive. Now you add them up, and that's your answer. And you'll practice this and have quiz-mes, and hopefully you'll get it correct. But again, let's put a star by that one. Okay, letter C. Triple a number, and we're going to use x for the number. So if we triple a number, that would be 3x, and decrease it by 6. And part of it is to become familiar with keywords. Decrease is subtraction. Now letter D, another very important one. 6 times, we know that's going to be 6. Now the word sum of a number and 2. How do we indicate that we're going to have this as a sum? Well, the key here, when it says this, sum, we need to put these two together. So this is 6 times the sum of this. And they've asked us to simplify. So we would then go 6x plus 12. Now this would be the start of it, and then this would be the simplification where we distribute. But the key here is when we have a sum, we have to indicate that it's a sum by putting it in parentheses. Then we can say 6 times that sum. Otherwise, you would just go 6x. Wouldn't be the sum of these. Okay, that wraps this up.